let's draw some amines. So when you have an amine has a nitrogen in it. So that's going to be our base, and we're going to draw the main carbon chain here. This is pentanamine. Pent means I have 5. Means I have 5 carbons, and then on carbon 1, I have an amine. So I'm going to draw my 5 carbons. 1, 2, 3, 4, 5. And on that first carbon, I'm going to put my amine, my NH2. So nitrogen likes to have, let's draw that out for a second. Nitrogen likes to have 3 bonds to it. So I'm going to have a hydrogen here and a hydrogen here. There we go, that's its most preferred form. So then I can fill in the rest of these. This carbon needs to have 4 bonds, so he's a CH3, CH2, 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 and also CH2. There we go, and NH. Now you can also shorten that to NH2. I just wanted to emphasize that that nitrogen likes to have 3 bonds, carbon likes to have 4. So sometimes when you're drawing these, it's like, well, how many hydrogens do I put on? So you're going to want to put 2 there on the end if there aren't any substituents on the nitrogen. In this next one, we're going to start with pentamine again, and that 1 is telling you that the nitrogen's on carbon 1. I could have put this nitrogen on any carbon, then I would have to give it a number. So again, starting with the 1, 2, 3, 4, 5 pentamine, I know I have nitrogen there. In this case, I have an isopropyl group attached to the end. So that N-isopropyl means instead of hydrogens here, I have, in this case, an isopropyl. Isopropyl, if you remember what those substituents look like, you have propyl, so you have 3 carbons, but you're attaching from the middle carbon. There we go. So this is a CH3, CH3. This carbon already has 2 bonds, so 3 bonds, so he only needs 1 more hydrogen. This nitrogen now has 2. He needs 1 more hydrogen there. And you could put that right next to it. I like to spell that out so I can figure out how many hydrogens I have. And then these guys are CH3, CH2, CH2, CH2. And this carbon has 1, 2, so he also needs CH2. So pretty similar to the first one, except now instead of having hydrogens here, I have an isopropyl group. So in the next one, now I have hexamine and a 2. So that means the nitrogen is going to come off of the second carbon, and I'm going to have 6 carbons. So I've got 1, 2, 3, 4, 5, 6 carbons. The 2 correspond to the amine. So I have 1, 2. I'll put it over here. That's where my nitrogen is going to go. And then I can see the rest of this. I have an ethyl group off of that nitrogen, and I have a methyl group. So I have an ethyl group, CH2, CH3, and I have a methyl group, CH3. And the rest of these are going to have as many hydrogens as they need to give carbon 4 bonds. This carbon has 1, 2, 3, so he only needs a CH. And this one needs a CH3. This nitrogen has 3 bonds, so he doesn't need any hydrogens on it. The last one, ethanamine, F, just 2. We've got a C and a nitrogen attached to that one. So this guy has, I'll draw this one out since it's only 2 carbons. If you wanted to do CH3, CH2, that's cool as well. And NH2. So there, ethanamine, it's like that. And there's nothing special about putting the nitrogen on the right-hand side. You could have easily put that on the left-hand side as well. To name these, so this is how we draw them. To name them, we're going to work backwards. We're looking for the longest carbon chain that has a carbon attached to the nitrogen. So in this case, I only have 1 carbon there. Instead of calling it methane, you can kind of figure out what the naming system is going to look like. I drop that E and add amine at the end. So this one is just going to be methanamine. Methanamine. I know I have bad writing, so I'm going to try to type these. This next one, I'm looking for the longest continuous chain. Here we go. This is the longest continuous chain. So that would have been, if it was just a alkane, it would have been propane, but instead of, I'm going to drop the E and add amine. And in this case, I want to indicate what carbon it's on. It's on the second one. It's on carbon 2. That's my 2 carbon. 1, 2. Either way I number it. I always want to get the amine to have the lowest number. In this case, it would be, doesn't really matter. This one I didn't have to number it because there was only 1 carbon. Now over here, I have a nitrogen. I've got 2 different alkyl groups. So up here, I have 3 carbons, and down here I have 4 carbons. So the longest chain with the nitrogen in it would be the 4 carbons, and I can start numbering over here at 1, 1, 2, 3, 4. So if I was an alkane, 4 carbons would be butane, but since I have an amine, I'm going to call it butamine, and I'm going to indicate that it's on, the nitrogen's on carbon 1, and then I have this other group here, which is going to be off of the N. So this is an N substituent, and it's 3 carbons. It's not propyl. Propyl would have been when the nitrogen was attached to this first carbon. This is an isomer of that. It's isopropyl. Isopropyl. So it's attaching a different carbon. So this is isopropyl N, isopropyl 1 butanamine. And the last one over here, I have 2 substituents. I've got 1 carbon, 2 carbons, 3 carbons. So the 3 carbon one, that's going to be my base chain, propane. But since it's amine, it's a propanamine. And I want to indicate which carbon it's on. I'll start numbering at this carbon here. 1, 2, 3. And then I just have to name these. So this is going to be an N-methyl and an N-ethyl. So I'm going to put them in alphabetical order. I'll have N-ethyl, N-methyl, 1. Let's bring that over. There we go. N-ethyl, N-methyl, 1 propanamine. So that 1 tells you which carbon on the longest chain the amine is being attached to. And then everything else is pretty similar to what we did before. If you have substituents off of the amine, then you label them with N's. Just like we would on a long carbon chain, we would number them with numbers. If it's on the N, off the N, we'll just put an N in front. So N-ethyl, N-methyl, 1 propanamine.